Hi, Lene Fischer, University of Copenhagen. In this model designer for raster data is part of a lecture at the university. In this case, I want to extract from an RGB raster image. I made this image from a drone flight just right after these conifer was planted, and I want to find every single tree and make a vector layer with points where the trees are. From that, I will make an input raster. That's the conifer new here. I will calculate in an index called vary, which takes the green minus the red divided by the green plus red minus blue. I want to extract those values higher than 0.01 in the raster calculator. That will be a Boolean. After that, I will polygonize so I get the data into vector. So polygonize raster to vector. It's the same result as in the previous one, but now it's in a vector layer. The vector layer has one field in the attribute. It's called DN, digital number, and I want to extract those with the Boolean that was one before, that was the trees. And I want to have areas larger than 0.004 square meters. From that, I will make a buffer on 10 centimeter, which is going to be dissolved. That means I will get a new layer with only one feature, but a multi-polygon feature. And from that layer, I'm going to make centroids on each multipart. This is how I'm going to make this model here. Let's start. I've already turned on the processing toolbox, and now I'm going to create a new model. At first, I'm going to give it a name. I'm going to find tree from RGB raster. I'm going to make it into a group called lecture class 2025. Then I can't write anymore. So, and I'm going to save it. I choose the input, which is in this case a raster layer. The raster layer will be RGB raster, and yes, it is mandatory. The next, I'm going to take the toolbox, and I always take my notepad to see what is going to be done. I'm going to take this one here and calculate this. I copy this because when I'm in this algorithm and making in the dialog, I can't remember, and so I simply copy this one. And I choose raster calculator. I take the raster calculator here and simply say, I'm going to calculate the vary index. My input is a model input. That was an RGB raster. And now I'm going to calculate here. These are layers. I only have one layer, so that is layer A. And if I double click, you can see I get layer A, band number 1. I have 3 bands out here. Band 1 is red, band 2 is green, and band 3 is blue. And it's now here I input my node here. Parentheses for the green, so that will be 2 minus the red one, so that was correct, parentheses, divided by parentheses the green plus the red minus the blue. And then I add the parentheses here, like this. Read the formula thoroughly through and see if you have put the parentheses correctly. You have put also plus and minuses correctly. You will have no information about illegal or incorrect formulas when you're making this here. I press OK. I don't change the output extent because I'm using the same extent as in the input. I don't change the cell size because I'm going to use the same as the raster image input. Now I'm going to check if it's going to be right. So I say output will be vary. Before I run it, I press save and run. This was a cut layer down here called Conifer New, and let's run and see how it goes. That was smooth and fast. And you see I get the new calculated here. Just to show you why I want data with a specific. You can see if I take this and delete everything which was below 0, I get a much more cleaner result. I will still get something which is not correctly. I will have small values in here, but this is what I'm going to calculate from. We go back to this one here. And I want to extract from with the raster calculator index values larger than this value here. So I take the raster calculator again. Like this one here. This is an algorithm output. And I want to take result here saying the raster layer I have, that's A, has to be larger. No, I think I take larger and equal 0.001. Press OK. I delete this one. And let's see if I get the correct result. And now you can see I get a Boolean 0 and 1. This is correct. You might wonder if I could have done this in the same here. So I put it in the same raster calculator. Yes, that's correct. That could be done. But this is a part of a lecture, so you can see how every step works. Now I'm going to polygonize. Polygonize raster to vector. And I'm going to use the algorithm output, where I'm taking this raster calculator, vary larger than, and I'm going to make it from band number 1. In this one here, I only have band number 1, and I'm going to get a field called DN, digital number, and I'm going to call this poly. Press OK. Save, run. The polygonize takes a little while. Close, and I can see I get this as a vector layer. Now you can see from the attribute table, I will get a lot of small polygons, some with dn equals 1 and some with dn equals 0. Now I want to have all the one with 1, but only those with larger areas. I want to exclude all the small ones here. And that is why I want to extract dn equals 1 and an area larger than this value here. So out with this one, back to the designer, and I want to extract by expression, and extract by expression here, I simply take this one from my notepad. I want to make an algorithm output which was vectorized, and I want to put in here this formula which was dn equals 1 and $area larger than this one here. I press OK, and I just want to see the matching features here. The matching features here will be resolved. Just the matching features. Save, run, and run again. Again, this polygonize will take a little while. Close, and now you can see we got the matching features here. It looks quite fine, but still I might have some which are more than one polygon. This was fine too, but I would have someone which are 2 polygons here, and I don't want that, so that is why I'm going to make a buffer and a dissolved buffer, so trees will be larger. So back here, want to make a buffer. I say buffer 10 centimeter. Dissolved. I'm using an algorithm output, which is a matching features, and I now here want to make a 0.1, and I want the result to be dissolved. Save, run. And finished. Now you can see I got nice small round trees, and I want to extract the centroid, but selecting this layer here, you can see it's a multi-polygon. So when I'm going to select I want to select a centroid from each single multipart. Let's do that. So I press centroid. And that will again be an algorithm output, and that will be buffered. And it says create a centroid from each part, and here it will be yes, otherwise I will only get one tree. So I press here, result, and that is my final result. So let's see the result here. Save, run, and it's complete. Now I got every single tree in here. There might be, it differs from each orthophoto you make, and there might be some smaller changes, but this is just a part of a lecture where you use both raster data and vector data. End of lecture. Sorry, I forgot one thing. I forgot to show you the model here. That was from class 2025, and you can see you can find it here and you can run it from here. That was the same as before. End of lecture.